Okay, what we're going to do now is have a look at reflections. Now, we'll look at reflections in the x-axis, y-axis, and the line y equals x, and then in the next video, we'll have a look at reflections in a line x equals something or y equals something. So it's a little bit different to what we've seen. So to reflect something in the x-axis, we use this matrix 1, 0, 0, negative 1. To reflect something in the y-axis, we use negative 1, 0, 0, 1. To reflect something in the line of y equals x, we use 0, 1, 1, 0. So basically what we're saying here, we're multiplying a top row and a bottom row, then you should see this becomes negative y. So, and here, this becomes negative x. So as a result of that, you should see some things start to have something should really make sense. So once again, we'll talk you through reflecting a point and also reflecting an equation. So we're going to do a point 5, 2 in the y-axis. Now, thinking about this point 5 and 2 in the y-axis, if that's our point there, 5 and 2, and if we're reflecting on the y-axis, where do you think it should go? Well, I reckon it should go to negative 5 and 2, because it's on the opposite side of the y-axis. That's where it's been reflected. But let's see how we prove that with matrices. So we put our reflection matrix first. So 1, 0, 0, negative 1. Sorry, this is negative 1 because we're reflecting in the y-axis. So we're using this this matrix here. And then set up our coordinates in matrix form, 5 and 2. And now from there, we end up with 1 times 5 will give us negative 5. 0 times 2 gives us 0. Now next row, 0 times 5 gives us 0, and 1 times 2 gives us 2. So our new sets of coordinates are negative 5 and 2, just as we thought before. Now let's have a look at what happens if we do it with an equation. So we've got the function y equals x minus 1 all squared in the x-axis. Now, if we've got x minus 1 all squared, we know it's going to look something like that. And if we're reflecting in the x-axis, it should look something like that. So you need to be thinking about these things in terms of what's going on, and in terms of what it's going to look like. So you should have an idea as to what you're looking at. So if it doesn't turn out, well, then you've got to think about why. So with this one, what we do, we set it up like we did before. So we have our x dashed and our y dashed will equal our transformation matrix, so x-axis. So we're going to use this one. So we've got 1, 0, 0, negative 1. Now multiply that by x and y. So now when we multiply this out, we'll end up with x and negative y. No, rather, we'll find that x dashed equals x and y dashed equals negative y. So once again, we want to rewrite this. So we've got a y, not a negative y, so this becomes y equals negative y dashed. So we rewrite our equation, and we write, instead of y, we put our negative y dashed equals x dashed minus 1 all squared. So then we want this just in terms of y, not in terms of negative y. So we have y dashed equals negative x minus 1 all squared. And it's a dash. And finally we write that as y equals negative x minus 1 all squared. And like we saw before, exactly the same, except it's reflected in the x-axis. So that's how you go about doing these kinds of reflections.